Hello everyone and welcome to my new Touch Designer tutorial. This one would be about SOPs and more specifically about a primitive SOP and even more specifically about some handy Python expressions that you could use in primitive SOP as well as in point SOP, in copy SOP and in some different cases. What we will do is create such kind of geometry that started from torus and just do some scaling and rotating and coloring of facets that creates this torus. This technique has its pros and cons, and the pros is that it's kind of simple. As you can see, the network here is very simple, just dozens of operators, but it's quite computationally heavy on CPU. As if I turn off the two of this, it's still not 60 FPS. But sometimes you can go up to 60. It depends on the complexity of your geometry and complexity of what are you going to do. Okay, here we have almost 60 and I'm recording now. So I'm lowering a little bit. On the other hand, if you will try to create even something like this with, for example, with instances, you will need to calculate the right rotations and the right scaling to do this, and it could be very tricky. You could also do this in vertex shader, but people don't not so much people like to use a GLSL because it's messy and you need to know how to code and you need to learn it somewhere. And here is, as I said, very simple. So let's start. I will turn off this container, create a new one, go inside, and I would show you everything with a torus because a torus has a complex geometry. Yeah, it has a complex geometry compared to sphere or box or I don't know, or rectangle. For using this technique, we will need to set primitive type as a polygon. Connectivity, you could leave it as quads or set it as triangles as you want. And I add a facet. I will add a sort, and I will add a primitive. Okay. Oops. What's going on? Oh, okay. In the facet top, many of you probably know this trick. If we turn on unique points and turn on compute normals, we get this faceted torus. We wouldn't do anything with sorting now. We'll come back it later. And in our primitive SOP, we will work. So what primitive SOP does is it's transforming, do scaling, translating, and adding some colors to the every face. Yeah, it's called face. It's called vertices, edges, faces, polygons, surfaces. So even though the operator calls a primitive SOP, it's not a primitives, it's a faces. And we have 80 of them, which called primitives here as well, because probably because it's a rectangle and rectangle is a primitive. I don't know why, actually. And sometimes we will need this information about how much primitives we have, so I wouldn't want to create a feedback loop errors, so I put info here in my facet. Oops, don't go. And I need the number of primitives. And let me show you with the color first, because it's super simple. Every one of these primitives, sometimes I would call it primitives, sometimes I would call it faces. It's like a synonyms, I don't know. Okay, synonyms for today. I can show you how they sort right now. To access them, we have a Wikipedia page on primitive class or on SOP class, but the most handy one is optimized Python expressions on derivative. Every primitive has these indexes that you could access with this expression. So, if you add an index here, it would become super bright, because indexes goes from 1 to, or from 0 to 800. So what you can do is you could take an index and divide it by the total number of primitives. And let me copy it everywhere so that it would be uniform color. And now it looks like this. And if you sort in your, not points, but your primitives differently, you will get a different result. For example, if sorting by X direction or by Y direction, yeah, probably I'll leave it sorting by Y. But you can also sort with, for example, proximity to point and add some point. For example, I don't know, math c times seconds and math costs. And now it goes like this. But the problem is it's also computationally, well, not super heavy, but still almost 1 millisecond. So probably I'll just leave it by Y now. And a good trick you could use here is you could add your attributes, and it will allow you to show your any of the values you have here. For example, I can create an attribute. Let me add some. I just call it attr. Set this to vec4, so it keeps 4 values. And in one I put our color. In another, to show you, I'll just put what is input primitive index. And if you now convert it to dot, you will have not points, but again the primitives, and we need our attributes. So as you can see, our first attribute, which is number 0, is our color. This goes increasingly from 0 to almost 1, and here is our indexes of our primitives. And most of the time we would use our indexes. which goes from 0 to almost to 799. Okay, what can we do? Well, let's do some transformations. Let's do translations first. What we have? For example, we have primitive normals and primitive directions. Let's take a direction, for example, and translate it in a direction, and in square brackets it sets 0 is x direction, it's a y direction, and this is z direction. So I'll change it accordingly, 1, 0 to 1. And here we have it. Okay. Maybe it's too much. We can multiply it by something. Okay, that's good. Not very exciting, but that's a good start. What else do we have? We have a scale, and we have an interesting Python expression called tdu.rand, and you need to put a seed for random in these brackets, and we can use index as a seed. So it will be me input print.index. And here we have our first doors. Oh, it was animated, so we can animate it like this. Math, sinus, and we took a sinus from our timeline, for example, multiplied, and our sinus goes from -1 to 1, and this is too much, so we can take an absolute value of this. Boom, 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 boom. Okay, maybe we will add something, so it not goes from 0, but from 0.3 to 1.3, probably, yeah. And the transform order is a matter, so now we have first a scaling and then translating, but if we set first translate then scale, we got a different looking thing. But this time I prefer this. And maybe we'll change and set different radiuses, or set a different seed. Okay, looks good. It's translate. Yeah, everything is alright. It's not rotation. It's scaling in for different integer in different directions, so it looks a bit like rotating. Okay, but it's still not super exciting. So let me bypass this one and add another one. I bypass just to save our FPS. Let's use a chops. we could use a chops to sample values from chops. Let's take, for example, a wave or LFO or noise, or let's take a pattern. Where is the pattern? Here is a pattern. And let's make some interesting pattern. We need the length should be equals our number of primitives. Ba-bam. Okay. Number of cycles, I don't know, let's do it the same as number of rows, like 20. Maybe, I don't know, set tapper, maybe, yeah. Let's set amplitude to 1 and offset to 1, so we have our values between 0 and 2. And let's sample it. Okay, let's add a null, alt with n, our null, and call it chop sample. Not a simple, but simple. Okay. Okay, what we can do with this? Let's do scaling, rotating. Yeah, let's do scaling. Yeah, scaling. Okay. So, what we need to type? We need to type to reference our operator, chop simple, channel number 0, and as a sample we took our index of our primitive. So me input prim dot index. Ba-bam, ba-bam. Oh yeah, it's got from to 2, and 2 is maybe too much. Yeah. Yeah, that's good. That's good. And let's animate it. Meters, seconds. Wee. Maybe not so fast. Wee. And you can experiment with a pattern. Maybe add some, I don't know. Not ramble. Whoa. Okay, let's leave it like this. Actually, I wanna see what did I have before. What was this? Oh, it was the same. It's a skeleton. Yeah, it was skeleton with a little bit of translation, but it looks more or less the same. So yeah, I'll leave it like that. And for third one, by the way, I'm not sure would I create a feedback loop or not. Okay, let's see, let's test. Let's take our primitive, let's feed it to here, because I'm gonna use the information about I don't know, about about normals, for example. Let's call it norm, and how it's called? Yeah, it's called me input prim normal. Me input prim normal, me input prim normal. And again we need to set a normal in which direction. So in X and Y and in Z. And here we have our normals. And now let's convert it to chop. Our information is per column. Our first row is names and first column ignore. And by the way, you could use this chop for instances, because usually if you convert, for example, torus to chop to SOP to chop, it will take the position of the points, but sometimes you would like to have a position of a primitives or faces, and you can do it with this. Of course, this is not positions normals, but you could use the positions as well. You just need to type me input prim position, position, center, me input prim center. Okay, and let's convert this to top. And the format RGBA is 32 bits. And let's create another top. Another top. Let's make a ramp. And again we can set our resolution to 80 by 1. And again and let's do something. Let's do periods, so it looks like tish. And use some composite, I don't know, multiply, I don't know, we'll see later, and add a new and call it top sample. So how to sample information from our tops? Let's do transform. Let's do translate. We need to reference our operator. Top sample, point sample, open brackets. I'll need to make it wider. And now you need to give information about the X pixel and the Y pixel. And let's X pixel would be me input prim index and Y equals 1. And in brackets we need our channel, so RGB, that would be RGB. Okay, here we have our problem with dependency loop detected, but since our primitives are all the same, we could we can just copy paste this one. We will use primitive 3 for our exporting. Primitive for our exporting. Yeah, let's make some order. It goes from this to this to this. And here but we wouldn't do any translation here. Okay, and here we would do translation, but we don't need to add some custom attributes. So is it working? Yeah, it's working. It's working and it's looking interesting. It's looking interesting. Let's animate our ramp. Again, let's use the simplest seconds multiply 0. Oh, 0, 1. Oh, too fast. And let's play with our composite. Let's turn on updative harming. Overlay. Nice. Berliner. Oh, yeah, probably. Yeah, I like this one. I like this one. No. Yes, no. Yes, no. Let me check some others. It's a benefit of using tops because you can do... Whoa! Yeah, I will leave this one. I'll leave this one. And I'll use another ramp with some colors. I like this orange and this blue. And this blue combined. It's nice contrasting colors. And I will use it as a colors for our primitive. Color which Hoop. By the way, color is additive, and even though it's called 0, 0, 0, actually it's 1, 1, 1. So if you leave me input color and add to my input color, you would get the values above 1, which is not good. So we don't need this. And we set our color, right, 1, 2. Maybe let's play with our period. Okay. By the way, what did I use before? And before I used translation. Yeah, it was just translation. I used different ramp, and it was Y film. Okay, let's set it to Y film. Why not Y film? I don't know, what does it mean? Y film. Whoa, good. Whoa. And you couldn't be very insane and put some function here, for example, function, something like I don't know, arc sine, radians. Yeah. Okay, I will leave it like this one. And the last, well, not the last trick. Also, I wanna show you how you can use such kind of expression in, well, in a point SOP it's more or less the same, but you could use it in tops. Oh, sorry, in chops. Quite often I use it with LFO. For example, I set it to ramp and let me have, I don't know, 4 channels and all of them the same, but I want to phase every channel a little bit. And I can't do it me input chan not sure. Me input chan, me input, I forgot how it's me input something. Oh, me chan index. Me chan index divided by or multiplied by 25. And let's set a trail to look it better. And let's show everything in a single graph. Oh, maybe sine would be. Yeah, let's decrease the frequency. And we have our phased channels. And if you phase it by different number, for example by 0.5, we have 4 channels, it differs a little bit, and it could be useful in different scenarios. And the same kind of expressions. And again, you could find it somewhere here on optimized Python expression, or you can go to SOP class, chop class, top class, and so on. And the last thing is you could use the same technique with different kind of geometry. You could import geometry. Let me do a file in. I have a file somewhere. Touch designer, external references, banana. Okay, I have a banana. Home. Oh, yeah, banana. And now we have a faceted banana. Good. How much primitives info, how much primitives do we have? We have quite a lot, so probably FPS would drop significantly, but I don't care. I just want to show you some tricks. Again, a primitive. Oh, by the way, I forgot to show you one thing. It's not obligatory to use a facet. You could not use facet, but it would be looks differently. and most of the time it doesn't look very nice. But sometimes this one, I don't know, maybe, but most of the time it's good to turn on a facet. Okay, so we have facet, we have primitives, and let's make a simple rendering setup. Of course you can render all of this as well. Okay, it's time for another expression. As you can see, our banana is not in a origin of coordinates. How can we change it? We could move our banana. Let's move it here. Add a transform, and we need to move the whole banana. As far as I remember, it's me center and the axis. Yeah, it took the center of a banana, but with using me center we just move it twice, so we need to put a minus everywhere. And now we I forgot to set the indices. And now we have a banana in the center. Good. We have banana in the center, we have geometry. Let's put some camera, let's put some lighting. And nothing is seen because our banana is very big. So let's home. Let's move it like this. And we could do the same with lighting, but what else we could do? We could copy parameter, paste bind, copy parameters. Another trick for you: paste bind, copy parameters, paste bind, and now our lights always looks in the same direction as our camera. So we have a direct lighting. Direct lighting will, for example, distant light. Okay. And the final thing is render. Render. Alright. And somewhere I also have a texture for it. Let's put our phone and let's find a texture. It should be in the same folder. Banana is a color map. Yay! Is it looking good? Yeah. Alright. Now we have banana. Let's show it. And let's do something super simple. For example, we didn't do anything with rotation yet. So let's do it. Again, the same. Me input prim dot index. It will rotate by our index, which isn't a good idea. I want to rotate on a random number, so I could use tdu.rand and this as a seed. So it will rotate from 0 to 1. So let's multiply it by, I don't know, 45 degrees. You know what? I probably will use just a top because it's simpler than writing all these expressions. Okay, let's resize our top. 32, and the amplitude 45 degrees, not monochrome. And so instead of this, let's do noise 1. Of course it's better to put a null, but I don't. Yep, yeah, it works. It works. 1, 2, and let's animate. And let's add some randomness. Spread to something. But what's good to think about is it's very heavy. Its FPS drops to 26. So probably for such scenario it's much better to use instances. But maybe you like this technique and you could use this as well. Now I want to make it faster. I want to do something really... no. 0.5. And let's also move it a little bit. I just want to end up with something crazy. You multiply by 0.2. Okay, and now we have this wiggly jiggly banana with a very nice texture, because texture stays on the same faces as before. Okay, that's it for today, and I'll put this file on my Patreon, but it would be available for everyone, so you don't need to pay anything, just follow the link and download it if you want. Thank you for watching. Goodbye till the next tutorial. See you.